Welcome to Faith and Science. I'm Dr. John Ashton. I think one thing that perhaps I've often taken for granted is just air, the air that we breathe, although we do hear quite a bit more about our atmosphere in recent time, in that we hear about global warming and how carbon dioxide is increasing in the air and how this will raise the temperature of the earth and cause some of the ice caps to melt and sea level to rise and so forth. Well, of course, I guess there are a lot of feedback systems within on the Earth's ecology there. Unfortunately, of course, we are destroying some of those feedback systems, like our forests, and I'm really concerned about the rate at which we're clearing forests. And also, too, I think, pollution in the sea, because, there's a lot of algae in the sea, and all these things contribute to the balance. Life everywhere contributes to the balance, and as we're eliminating life, we're going to be causing problems. But I think the other thing is, too, that probably in the past the carbon dioxide content was a lot higher. I know often people talk about the oxygen level being much higher, but I think a higher oxygen level is likely to cause more problems, actually, whereas a higher carbon dioxide level, in actual fact, may be slightly better for us in terms of, our breathing, our metabolism, and so forth. And certainly plants like a lot more carbon dioxide, or just a little bit more. But it's interesting, the composition of the air and the way the air is on the surface of the earth is quite fascinating. So the air close to the earth's surface, of course, is heated by light energy from the sun. And after the air is warmed, it becomes less dense and rises upward. And this means that the air near the earth's surface maintains a temperature in which life can exist. So it seems that the density of air is just right to maintain our temperature at our distance from the sun. Now, the movement of warm air from the surface rising upwards, of course, creates air currents, which we know is wind, and they're an important part of the Earth's ecosystem as well. For example, they carry away carbon dioxide from areas that overproduce, such as in particular our cities at the moment. But of course, and they move oxygen to areas in need of it. And it amazes me how you have these huge urban sprawls and there's hardly any trees, and yet we can still run all our motor vehicles that are, again, burning the oxygen. They're taking the oxygen, combining it with carbon in the fuel and producing carbon dioxide. And plus we're breathing in the oxygen, and yet there seems to be enough. It's amazing, the reservoir of oxygen that there is there. And of course, if the atmosphere composition was much different, for example, if it was 17% oxygen instead of 21% oxygen, then too little carbon dioxide and too little carbon dioxide, etc. So in other words, we just got to change the composition of the atmosphere just a little bit. The atmospheric pressure would be either higher or lower. And again, significant changes in atmospheric pressure would very much affect life on Earth. You think about the air has just the right density for birds to fly and to create lift, and for planes and so forth. And all these things fascinate me. It's very interesting. We often forget about air pressure, but the air pressure, of course, 76 millimetres of mercury, it's quite a significant amount of mercury, or 34 feet of water, but it seems to be just right for life, to balance life. Again, if the air was much thinner, many of the millions of meteorites that are now burned up as they reach the Earth would continue and would not get burned up, and would continue crashing down and causing fires everywhere. So again, it's at just the right atmosphere to burn up most meteorites, and of course really big objects coming through from outer space are generally sucked up by the massive gravity from Jupiter, Uranus and Neptune. So again, the structure of the solar system is such to protect us from these really big ones. And then of course oxygen protects us, the air protects us from our little one. You know, even when we think about just in our soil too, I was reading some statistics that an estimated that an acre of farm soil, 6 inches deep or 150 millimetres deep, and an acre would be it'd be about 4,000 square metres, I think. It's roughly an acre anyway, about that. If you look at that, has several tonnes of living bacteria and almost a tonne of fungi. And it's amazing amount of life that is just located in the soil too, under the air. But I guess I need to get back onto the air. You know, another part of the atmosphere, of course, is water, and there's an abundance of water on the Earth's surface, and that's what distinguishes our planet from other planets. So the Earth's hydrosphere, of course, consists mainly of the oceans, but also all the water surfaces on the world, including the land, sea, lakes, rivers, and underground water. And, of course, then there's the water in the clouds too. And it's interesting that if we look at the oceans cover, about a large percentage of the Earth. I think it's about 75% of the Earth is roughly covered by water. But if the water was spread evenly over the Earth and the surface of the Earth was smoothed out, the water would cover the surface of the Earth by about 2.5 kilometres. And it's one of the things that is concerning, of course, is that 97.5% of the water on the Earth is salty. So there's only about 2.5% of the available water is fresh water, and most of the fresh water, nearly 69%, nearly 70% is ice. So there's some fascinating aspects here. But another fascinating aspect is that the water is H2O, so it has a molecular weight of 18. And, of course, a nitrogen atom has a molecular weight of 28. And so that's why our water floats. The water vapour floats. And it's amazing that the density of water vapour and everything just matches out. So we have this cloud system that will float in the air. And that's another thing that amazes me is the cloud system that provides, some shade and sunlight, brings rain and transports the water around. So the clouds, of course, transport the water, and of course the salt water is distilled by the sun, evaporates, goes up, condenses, becomes clouds, and then those clouds, using the fact that warm air rises to generate air currents, these air currents help carry that water and drop it back over the land where it's needed. So even this cycle is just amazing. It's so neat. It works so well. It's something, though, that we just take for granted. And, of course, a lot of us living in cities today, we turn the tap on and we get water, but we forget where that water comes from. Some of the water, of course, comes from underground. Some of it is pumped out of rivers and purified. Some of it comes from dams that have collected the rainwater in streams. But ultimately, all that water has somewhere or other come via this water cycle that involves, and if the atmosphere wasn't just at the right density that it is, the water cycle would be very different, probably wouldn't work, and hence wouldn't support life. So our atmosphere, of course, is primarily a nitrogen-oxygen atmosphere, and this enables the proliferation of little organisms that breathe oxygen. But another fascinating thing is that the oxygen level in the atmosphere, part of that becomes ionised in the upper atmosphere and forms the ozone layer. So if you think of a molecule of oxygen as 2 oxygen atoms together, well, it's possible for 3 oxygen atoms to form a molecule, and that molecule is ozone. And that ozone is just at the right level to block loss of the ultraviolet solar radiation. So ultraviolet radiation from the sun can be quite damaging. There's different types of ultraviolet, so it's very, very short wavelength, ultraviolet A, B and C. Some of it, of course, is important for us, for our health. So some of that radiation, when it strikes our skin, produces vitamin D. It also has a sterilising effect and helps to sterilise things on the surface from bacteria and so forth. So the ultraviolet light, but it's regulated to just the right level. And we know that if the ozone layer was completely destroyed, and people have been very concerned about this in the past, you may recall that in the past we were very concerned about refrigerants that were used, these fluorine-based refrigerants, which, when escaping into the atmosphere, help break down the ozone layer. But, of course, chlorine does the same, and we practice a lot of water chlorination around the world as well. And we know that in many places around the world, like over southern Australia, the ozone layer has been significantly diminished, and there's a lot more ultraviolet light getting through in those areas. And some people, so I've read scientific reports that if the ozone layer was completely destroyed, then it would possibly end life on Earth as we know it. So, and that's why scientists were very concerned about this and have changed the types of refrigerants that are being used and trying to minimise the amount of these chemicals getting into the ozone layer. Fortunately, there's a mechanism where the ozone layer reforms slowly, but relatively slowly. So if we send out a lot of these man-made chemicals into the atmosphere, it destroys it, but the atmosphere of radiation on the oxygen up there slowly reforms the ozone layer. Also, the water vapour that is trapped in the atmosphere, and some of these other gases too, provide what we call the greenhouse effect. And that, again, just helps regulate and preserve our temperature on Earth to be a reasonably uniform Earth. So the greenhouse gases, of course, are water vapour, carbon dioxide, methane and ozone. And if it wasn't for these heat retention gases, the average surface temperature is being calculated to be about minus 18 degrees would be the average temperature. So life would be very much colder. The average temperature on Earth, by the way, is calculated to be about plus 15 degrees centigrade out of interest. So it would be significantly colder. You know, there's just so many things that line up that, again, point to our planet being created and designed, and this whole system designed, and the properties of the molecules and atoms that make up this atmosphere. Like, you know, I've talked about it before, the property of water, that as it cools, it contracts and it contracts till it gets to 4 degrees, and then it begins to expand, and then it freezes. So the solid water floats instead of sinking, as opposed to, you know, most other elements and compounds. As they cool, they get more and more dense. And this is the fact that water becomes less dense just at that time. Just its structure changes just at that time. The bondings change. And I remember, it would be 50 years ago when I was doing postgraduate studies. There was another guy there doing his postgraduate work looking at the structure of water and trying to understand more about the bonding that took place in water. And it's only in recent years that scientists have really understood this. And I think one of the things that is very important, people often overlook, is, when we have this theory of evolution, when we've got the Big Bang theory and all this sort of thing, it's fascinating how, according to the theory, that atoms sort of formed and their structure formed. So where did all these what about the design? Why did they form in this particular structure where each one has an additional proton and lines up? Why not some random arrangement different? And there's so much design. I think I've spoken about this in earlier programs too. There's so much design within the nature of the forces, the structure of the nucleus, this sort of thing. And as James Clerk Maxwell, one of the greatest physicists ever, pointed out, how did atoms evolve? And then when you think about it, these atoms have to have particular chemistry. And we take some very simple atoms, basic atoms, hydrogen, oxygen. Hydrogen's atomic weight number 1, oxygen number 8. They've got to combine and have these structures so that in this liquid form it behaves in this particular way, so that then suddenly the bonding changes when it gets to 4 degrees before it freezes. Or again, we find that this freezing point of water just happens to line up and be relevant to the surface temperature of Earth, which is regulated, as I said, by the atmosphere and so many other factors, how far away we are from the sun, and so forth. There's so many things that just have to line up, and they've lined up perfectly. Now, people say, well, there's so many 200 billion galaxies, and there's so many million stars in the galaxies, and sooner or later you're likely to have a planet that lines up. But you don't have to look very long at probability and statistics to say, whoa, hang on, the probability of this all lining up, it actually exceeds the number of atoms in the universe, let alone the number of stars in the universe. And this is one of the things that convinces me that creation is real, that God is real. And when you combine that with the accounts that we read in the Bible, for example, I was just reading this morning, last night in Acts chapter 12, the miracle of Peter being locked up in prison. Now, Peter, here was this apostle who had lived with Christ, had seen the resurrection of Christ, and became a powerful witness for him. And Herod, the king, was not very happy. He wanted to wipe Christianity out, and he had Peter arrested and put in jail. And it's interesting, the account, when you think about it, that here's Peter, and the Bible said 4 squads of soldiers. So a squad of soldiers was 4 soldiers. So 4 lots of 4 soldiers were assigned to guard him. So that's each shift, each watch. So he had 2 soldiers chained to him, one on either side, literally chained to him, plus 2 guards on the doors. And the account says that an angel came, broke the chains, and Peter got up. And it's interesting that the account records that Peter thought he was dreaming. It was so surreal. Peter thought he was dreaming until the angel led him outside into the real world, and I guess seeing different things around, the angel disappeared. Peter saw where he was. He was no longer in prison, changed to 2 Roman soldiers. He was out, and of course he went to the place where the apostles were. You remember, I think it was Rhoda came to the door, and she saw Peter. She was so excited she ran back, didn't open the door. And that is so true to life, of someone doing that. Hey, the news that Peter was there was more important than opening the door to let Peter in. And there's so many little things like this. And then the apostles didn't believe it, and then they went and there he was. And of course it was real. And then the fact the soldiers were executed afterwards, because there was no explanation for how Peter could escape. And These are things that were witnessed by people. These were real events that occur, and that's why people gave their lives for this message. And to me, that makes a whole lot more sense. Creation by the God that sent the angel that freed Peter, that resurrected Christ at that time. And of course, when we, consider the evidence for the resurrection of Jesus, I was just reading this morning Gary Habermas's book, The Historical Jesus, or a chapter from it, The Historical Jesus. And it's very interesting, so much from the historical reports that went to the emperors from different historians about Christianity, what Christianity was like. But in particular, in 1972, a very ancient Arabic translation of Josephus's work was discovered. And of course, Josephus talks about that Jesus was resurrected, and there have been some critics that have said, well, hang on, this sounds like there's been a bit of editing here by Christians afterwards. And what Habermas is saying, and other people are saying too, some of the other scholars, that the discovery of this very ancient Arabic manuscript, which is slightly different, but still has the wording is just very slightly different, but it's very unchristianised, if you could get that. So phrases that are likely to have been inserted may have been edited by Christians are not there. But it still talks about the resurrection of Jesus Christ. It was seen by the disciples 3 days after his crucifixion on the third day. And that was a report that Josephus was recorded. So this is, we have this evidence, plus the testimony, as Peter writes, we aren't following cunningly devised fables. And then, of course, you have Paul's conversion, who actually was visited by Jesus and had that experience with Jesus and converted from being a person persecuting and wanting the murder of Christians to an advocate of one of the strongest advocates of Christianity. And that's powerful evidence. Paul's conversion is very, very powerful evidence that Jesus is real, because Paul met Jesus. Jesus spoke to Paul. So when I look at that evidence there, and the number of eyewitnesses that saw Jesus afterwards and reported, and the fact that Christianity spread so quickly, and people gave their lives, were prepared to die rather than sort of give up Christianity, is really powerful evidence that those miracles, so many of those miracles, are real. And if those miracles are real, then the creation is real, and the supernatural God is real. And of course, I've experienced so many personal answers to prayer that for me, it's not an issue. God is real, and that's why I'm so passionate about this. That's why I'm, passionate about trying to tell people to believe in Jesus as God for salvation, because, the evidence is all adding up that Jesus will return. It won't be that long before Jesus does return. At his return, those that have chosen Jesus will be resurrected, and, or translated, they'll be taken off the surface of the earth to be with God, while God destroys the earth and leaves it desolate for 1,000 years, and then recreates the heavens and earth again as a new place for us to live without sin. No more sin then, the end of sin. God puts an end to evil in the world. And to me that makes so much sense to what I see happening around. And it gives us hope. It's a fantastic message. And of course, one of the reasons I'm involved in this little program, Faith and Science, is that I meet people that think that, science has disproved the Bible. Well, science hasn't disproved the Bible. Science more and more is confirming the Bible everywhere we look. I guess I should get back to some of these things that, the Earth's atmosphere contains a huge amount of water, and it's an amazing system, a really amazing system. One of the things that worries me is the disappearing of the rainforests. They once covered about 14% of the Earth's surface. Now they cover a mere 6%, and they may not last that much longer. There's so much that we could talk about in terms of the amazing facts of our ecological system, the ecosystem Earth, that just works and just fits. And as I think about just our simple system, air, and the fact that we have this oxygen to breathe that keeps us alive, and how it is regulated, how the temperature is regulated, how we have water, and then when I think of how much pollution we're generating and smog and so forth, it certainly makes me think, how much longer will it all go on for? And I think one of the things is, of course, that we can get so engrossed with all these problems today and trying to fix these problems that we can forget that there was a creator who created it, and really the only solution is going to be a complete refix, and that's what God promised. And I guess the other thing that is interesting too is that we have this 7-day week, and there's no natural cycle that that is obvious, sun, moon, stars or something. There's a 7-day cycle. The 7-day cycle comes from the Bible, and we know that it's to remind us that God created the earth in 6 and the heavens and the earth in 6 literal days. And I think forgetting that cycle has been another part of the factor that people have forgotten about creation. That's why keeping Sabbath and remembering that God is not only our creator and redeemer, but each week remembering that keeps our focus where it should be, on our Saviour. You've been listening to Faith and Science, and remember to re-listen to these programs. Just Google 3ABN Australia, or one word, .org.au. That's 3abnaustralia.org.au, and click on the listen button. You've been listening to Faith and Science. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.